Hey class, Absolute5 here, and today we're finally going to be done with exponents. So this is going to be exponents part 6. Finally, right? We've been doing exponents for a while now. Now this is the last part. Let's start off with an example. What if I gave you an example where I have x to the second over x to the fifth, right? So what's going to happen is I'm going to end up getting a negative exponent. And now when you first see this, you're kind of like, how do you work with a negative exponent? Or what even is a negative exponent? You're trying to figure that out, right? So let's write it out the long way first. The long way meaning x to the second over x to the fifth. I get x times x over x times x times x times x times x. And then I start canceling out the x's, and I'm left with 1 on top. So 1 over x to the third. So there's a correlation that whenever I have a negative exponent, right? Try to draw a little arrow there. There you go. Whenever you have a negative exponent when you have a negative exponent, it goes down to the denominator more or less. And interesting enough, let's have it the other way around. How would I have it the other way? Oh, let's say I have it as x to the minus 5. No, it wouldn't make sense, no. The idea is this. What happens when you have an exponent in general when it's like this? So let's write it out. Negative exponent. But we're going to specify, we're going to put it as the numerator. We're going to get to the denominator. Don't worry, we're going to get to the denominator. If a is a real number other than 0 and n is an integer, then a to the negative n equals 1 over a to the n. So basically, whenever you have a negative in the exponent, it's just going to go down to the denominator. So if I have x to the negative 8, it's going to be 1 over x to the 8. So generally, we don't like to work with negative exponents. So whenever you have a negative exponent in the numerator, it goes down to the denominator. So then you're probably wondering what happens if it's in the opposite. What if we have a negative exponent in the denominator? Well, let's see what happens. If I have a negative exponent in the denominator, let's say I have this as the example 1 over x to the negative 2, it's going to do the reverse. It's actually going to flip up into the numerator. So it's going to be like this. It's going to go 1 times x squared, which becomes x squared. So essentially, well, technically, sorry, I did that wrong. This is what's happening. As this is going up, as the denominator is going to the numerator, this 1 goes down to the denominator. So it's going to be positive x squared over 1. But in reality, it's just going to be x squared. So let's write that out in general, what that means. So it's going to be negative exponent denominator. It's going to say the same text in the beginning, so I'm not going to write that out again. But the difference, though, is it's going to say, let's see, it's going to say 1 over a to the negative n equals a to the n. So if you had both those two side by side, it will look like this. This is for numerator, and this is for denominator. Where if I have a to the negative n equals 1 over a to the n. And for the denominator, it would be 1 over a to the negative n, which would be a to the n. So you see how whenever you have a negative exponent, depending on where it is, you're either going to flip it up or you're going to flip it down. So if it's in the numerator, it's going to flip up. If it's in the denominator, it's going to flip down. Sorry, I said that wrong. If the negative exponent is in the numerator, it's going to go down. And if the negative exponent is in the denominator, it's going to flip up. There we go. I said that wrong. I was like, oh man. Anyway, let's work out some examples real quick. So let's work out, first off, what is this? X to the negative 3. Something easy. It's going to go down to the denominator, x to the third. And some of you would stop, and I'll tell you no. In this case, you have to calculate. So it'll be 1 over 5 times 5 times 5, which is 1 over 125 as your answer. Next example would be negative 3 to the negative 4. It's going to go down to the denominator, but you also, this is positive now. So then you write it out 4 times, and you'd get 1 over 81 as your answer. Now, what if it's the opposite direction? Let's try this one. 1 over, sorry, not negative. Let's say 6 to the negative 2. It would flip up to the numerator, and the numerator would, and it would flip up to the numerator, and then this becomes what? Whoopsie. This becomes 36 as your answer. So it's kind of self-explanatory how you work things out, but let's try this one. This one's a little tricky. So now, don't forget the rules that we talked about where you're going to extend, I think it's the power rule, no, not the power rule, I think it's the quotient rule that we just did before, where you extend the negative 3 to the numerator and the denominator. So remember, there's a little 1 here, and there's a 1 down there. So it's going to be 2 to the negative 3 over x to the negative 3. Therefore, I'm essentially going to flip both the terms at once. So this numerator is going to go down to the denominator, and this denominator is going to go up to the numerator. So it's going to be, and you change the sign. I forgot to mention that this whole time. You're supposed to change the sign as you flip. So x to the third, negative 3 becomes x to the third, and 2 goes down to the denominator, and you change the sign to become positive. I'm not finished because I got to calculate what 2 to the third is, which is x to the third over 8. And that's it for that problem. Let's do another one. Just checking my notes for examples. Oh, this one's good. 6 over 7 getting raised to the negative 2 power. This becomes it becomes 6 to the negative 2, and this becomes 7 to the negative 2. But then you flip the numerator into the denominator and the denominator into the numerator, and you change the signs of the exponent. So then this becomes 7 squared over 6 squared, which is going to be 49 over 36. Can I reduce that? No, I cannot. So we're done with that type of problem. So I'll give one more problem for homework if you guys want to do it. You don't have to, but it'd be fun to try. Yeah, let's have p to the negative 4 over q to the negative 9. Sure, why not? Figure out what that is, and let me leave your answers down in the comment section below. Okay? So that's the lesson for you guys. I hope you enjoyed it. This has been, like, share, and subscribe to my channel. Mash that bell button for more content, and I'll see you guys next time with another video. This has been Absolute 5. I'm Roger Palomino. Math is infinite because there are infinitely many possibilities. And don't forget, don't hate, calculate.